All right, lesson 12.2, we're going to talk about what's called a series and summation notation. And so we're going to learn how to evaluate the sum of a series expressed using sigma notation. And sigma is a big letter E that we'll talk about here in a minute. Now, yesterday we did sequences. And sequences are just, set of numbers that have an order to them, all right, separated by a comma. A series, on the other hand, is still a sequence, but this sequence then has plus signs between each number. So in other words, we're going to add all the numbers up. Okay? So a sequence is just a list of numbers separated by a comma, where a series is we're going to take that group of numbers and we're going to add them together. Okay? Now with series, we could have an infinite series, like if we add up all the natural numbers or add up all the whole numbers. Okay, that would be an infinite series. And they don't have sums. So we're going to find, usually what we're going to do is we're going to find what's called a partial sum. And we're going to be using subscript notation again. So if you see S sub 1 or S sub 2, S sub 3, S sub 4, the subscript number there tells you how many numbers you're going to add. Okay? So if there's a 1 there, I'm only going to add one number up. Okay, that's pretty easy. All right? So we get lots of them. If there's a 2 there, we're going to add in 2 numbers. A 3, we're adding 3. And a 4, we're adding 4 numbers. Okay? So a series can also be represented by what's called summation notation, and that uses the Greek letter sigma. All right? And Mr. Hagar was looking for that, and I actually remembered where it was at. But we're going to, and if you want to know, you're going to have to ask him later. I'm not going to tell you where it is. Okay? That'll be a way you can check your answer. Okay? All right? It's on your calculator. Okay? All right? So here's what this means. Okay? This means, all right? So we're looking at these. Oops, I don't want that one. Please don't mess with it right now, though. All right? So we have the K is the variable we're using. When we do sigma notation, we're using K instead of X or N or T. The 1 here, or this number here, is the starting value. So that means we're going to put 1 in for K first of all. And the number up here at the top is the last value I'm going to use. And then we have, this is the explicit formula or the function that we're going to use to calculate. So what this means here, okay, is I'll put 1 in for K, find that number. Put 2 in for K, 3 in for K, 4 in for K, 5 in for K, and then we will find those values and add them up. Okay? So here's what it says. I would say it this way. This is a sum as K goes from 1 to 5 of 2K. And that just means that I start with the first number 1 and use all the numbers up to 5, put them in for K, find those values and add them up. Okay, so using summation notation, this first example says write each series in summation notation. So what we need to do is we need to find all of these things. So we need to start our starting value, our ending value, and most importantly, our explicit function, our explicit formula. All right, so we need to find the formula here, and one of the things that I put on the video for yesterday that I would like you to think about doing is making a table. Okay? It's the easiest way to find the explicit rule for the most part. Okay? So we're going to look at what letters we were using yesterday. N is my term number, and A sub n would be my term value. So how many terms do I have here? 5. Okay. So we have 1, 2, 3, 4, 5. Okay. And then we want to find if n is here. Okay. And then we have the numbers 4, 8, 12, 16, and 20. Okay. So what I want to know is, what is the relationship that gets me from n to a sub n? Okay. So those are multiplied by 4, right? Okay. So if I had a rule here, it would be 4n. Okay, that would be my explicit rule, because we're taking each of these numbers, 1, 2, 3, 4, and 5, and multiplying them by 4 to get these numbers here. So it says find a rule for the kth term. So a sub k would equal, in this case then, 4k. Right? That's my explicit formula. Right? So then when I write this, I do the sum. Okay, make that sigma is what that's called. And k starts at 1 and goes to 5 for 2k, or 4k, excuse me. 4k. And that would be my answer. Now, one of the things I want you to understand is it doesn't have to start at 1. Okay? You can start at 2, 3, 4, 5. It doesn't matter what number you start at. Okay? You can choose it. All right? Okay? That would be totally up to you. Okay? And sometimes it's different. Okay? So let's look at another one. Okay? Now, here's one that alternates numbers, the signs. We have -1, +1/4, -1/9, +1/16, -1/25, and +1/36. Okay? So they actually give us a little caution over here. Okay? They tell us that we're going to use -1 raised to the power of k plus 1 if its first term is positive, and -1 raised to the power of k if the first term a sub 1 is negative. Okay? So we're going to, first of all, to find the rule here, we're going to ignore the fact that there are positives and negatives. Okay? And so I'm going to make me a table. Again, I'm going to go ahead and actually make a real table in this case. So I need, what is there, 2, 4, 6 of them. So I need 6, 1, 2, 3, 4, 5, 6. Okay. All right. Let's bring it down here. And come on, cooperate with me. All right, oh, that's fine. I can use it. Okay. So here I have my values of n are here. So we have 1, 2, 3, 4, 5, and 6 because I have 6 terms. Okay. And then we have 1, 1/4, 1/9, 1/16, 1/25, and 1/36. Okay. Now, all of these have a denominator, don't they? All except for the first one. Does the first one have a denominator? It's 1, isn't it? Okay. So what's the relationship between these numbers in the ends and these numbers over here for a sub n? It's 1 over what? 1 over a squared. Okay. This is 6 squared, 5 squared, 4 squared, 3 squared, 2 squared, and 1 squared. Okay. So my rule here would be 1 over k squared. Okay. Now, this is where then this little rule comes in here. Says, so for alternating signs, is this first one positive or the first one negative in this case? Negative. Okay, the first one's negative. So that means I'm going to use this one here. Okay. So I'm going to put in front of that -1 to the power of k. And I'm going to explain how that works to you. Okay. All right, now, so we put 1 in for k first, right? Okay, for the first term, we put 1 in for k. All right. What's negative 1 to the first power? Negative 1, okay? And 1 squared is 1. So we would have negative 1 times 1, which is negative 1, okay? What if I put 2 in here for k? What do I get? What's negative 1 to the second power? It's 1, right? If I take negative 1 times negative 1, I get 1, okay? And then put 2 in the denominator for k, I get 4. So I get positive 1 times 1/4, which is positive 1/4. Okay? Put 3 in for k. Well, what if I have negative 1 3 times? Okay, then that's going to be a negative, right? Okay, so I'd have negative 1 times 1/9, okay, which gives me the negative. Okay? So whenever there's an even number in here for k, it's positive. When there's an odd number in there for k, it's negative. Okay? So here we have, put our summation notation. Okay? So our k goes from 1 to 6 in this case, because we have 6 terms. And then my rule is going to be negative 1 to the power of k times 1 over k squared. And you don't always have to, like I said, you don't always have to start with 1. Sometimes you might start with 2 or 3. Okay? It just kind of depends on the problem. Okay? All right, so in example 2, we're going to expand each series and then find the answer. So what we just did is we had the series was expanded and we wrote it in summation notation. Now we're going to take the rule and expand it and actually find what that sum is. All right, so here's what we do. We're going to put k, the value of k in for k, all right, and then just add them up. So we have 1 over 3 squared plus 1 over 3 cubed plus 1 over 3 to the 4th plus 1 over 3 to the 5th. Okay? So all I did is put the numbers 2, 3, 4, and 5 in for k, and then I'm going to add those together. Okay? You like how that's nice and straight? Okay? So we have 1/9 plus 1 over 27 plus 1 over 81 plus 1 over 243, right? And so I expect when you find this answer that your answer is going to be a fraction. Okay? Will your calculator do that for you? Will it add those 4 fractions together? Okay. All right.
It also does it if you do the regular expand with that too, it'll put it as a fraction.
Okay. It did when you did it with the calculator?
Yeah.
All right. I'll show everybody just for because you're still going to have to show me this work. So, okay. So if you take your calculator and you remember to turn the smart ink off, okay. All right. So if you go to Alpha and Window, you can see that wonderful Sigma. Oops. I need to quit first. All right. So Alpha, Window, and number 2, there's Sigma. There's all your stuff right there. So we've got, and you can put any letter you want there. Right? But what letter is easiest to use? X is. So you might as well just use X. So we put X here. And then we're going to start at 2, right? And go to 5. Oops, not 55, but 5. Oops, come on. Delete. Okay. And then I'm going to put, oh, it's a fraction, right? Alpha, y equals fraction. Hey there. Oops. Come on. Maybe it doesn't like the fractions. Or maybe I just hit something else. Must be. Okay, what was the numerator? 1. In the denominator we have 3 raised to the power of x. and hit enter, and then math and fraction,
Well,
and there you go.
yeah.
Yours was already in a fraction?
Yeah.
Okay.
There's
All right. Yep. Just depends on the setting. So
makes everything so much easier. Huh?
where am I looking for here? There we go. Calculator.
That's where that was. What?
All right. So there's it on the calculator. So my answer then is going to be 20 over 2, or 40 over 243.
And one times that makes sense out.
So if I got a common denominator here, I'd have 1 over 243 plus 3 over 243 plus 9 over 243 plus 27 over 243. And so when I add the numerators, I get 40 over 243. Okay?
Wow.
All right. So where else did you find that, Shelby?
Math 0,
Math.
0. Smarty.
No, it's dummy because it. Or maybe it's just me. It's probably me. All right. So math and 0. Okay. Summation. Okay. All right. I don't think that's on the 83 though, so I'll have to
I know
look.
that's where that was.
I'll have to look. Okay.
I thought it was somewhere.
All right. So, all right. Letter B says k goes from 1 to 6 of k squared minus 10. Now this one, oh my gosh, the calculator would be way easier. Okay. But you have to expand it. So you'll have the answer, but you need to expand it first. So that the expanding part here is where it gets a little bit more trickier. So we have 1 squared minus 10 plus 2 squared minus 10 plus, I might just have to take your calculators away for part of this. 3 squared minus 10 plus 4 squared minus 10 plus 5 squared minus 10 plus 6 squared minus 10. Okay. So you have to show me your work to get the expansion. So this would be 1 minus 10 is negative 9 plus 4 minus 10 is negative 6 plus 9 minus 10 is negative 1. 16 minus 10 is 6. 25 minus 10 is 15. And 36 minus 10 is 26. Okay. So now, this is really easy to add. All right? It really is. Because 9 and 6 is 15. Right? Negative 9, negative 6, negative 15, positive 15. 6 plus 26 is 32, minus 1 is 31. And I didn't need my calculator for that. Okay? All right? All right. And yes, you can do it to check. 2 more. Okay. Find the sum of a series with many terms can be tedious, unless you have a calculator. All right, you can derive formulas for the sums of some common series. So we have what's called a constant series. Okay. In a constant series, that just means we have the same number over and over again. Okay. And so for a constant series, we will have, if we just have some number c, we're just going to do whatever n times c is. So however many times we add them up, we just multiply them. Okay, that should make sense to you. Okay. If I add 5 10 times, it's easier to do 10 times 5 than to do 5 plus 5 plus 5 10 times. Okay. If we have a linear series, that would be like k, then we have a formula that's going to go along with that. And we have one also for a quadratic. So we have some specific formulas here to use. Or, one of the things that, I mean, for you guys will be able to do is you'll be able to use your calculator will do these things for you too, much easier. So, They aren't calculators. So here we got the sum as n goes, k goes from 1 to n of c, then we just multiply them together. If it's linear, then we're going to take the last term times 1 more than that and divide it by 2. Okay? N times n plus 1 divided by 2. That's actually pretty easy. And if it's quadratic, k squared, then we'll do n times n plus 1 times 2n plus 1 and divided by 6. Okay? It's really not that difficult to do. All right. So let's look at the constant series first of all. It says find as k goes from 4 to 10 of 6. Right? So I could do the summation formula first of all. So that means I have, there are 7 terms, okay, from 4 to 10. So 6 times 7 is 42. Okay, that's one way you could do it. Or I could expand it and add them together. Okay, so I have 6 for 4, 6 for 5, 6 for 6, 6 for 7, 6 for 8, 6 for 9, and 6 for 10. That's why there's 7 of them. Okay, it's not 10 minus 4 gives me 6. You have to include the 4 also, which is why there's 7. It's kind of like when we were talking about digits the other day, right? From 0 to 9, there are 10 digits, not 9. Okay? Right, so you have to think of it in that terms of that. Okay, and you can do it either way, and you could even put it in your calculator, and it would give you the answer, right? Okay, which that's even more likely to be right. So maybe what I'll do is let my third hour use some during class time. All right? Okay? Linear series. Right? We can use the formula. So here if we have the sum as k goes from 1 to 8 of just k, which means we're going to take the numbers 1, 2, 3, 4, 5, 6, 7, 8, add them together. So we could expand them and find the answer. So by just adding 1 through 8 and get 36. Or we could use the formula in this case, which says I take the value of n, which is 8, and what's 1 more than 8? 9. So 8 times 9 is 72, divided by 2 is 36. And that's actually faster than plugging all that in your calculator too. Okay. So for the, if it's linear, okay, we just have k here. Just add those numbers together. And if it's quadratic, the summation formula, it's a little bit more difficult formula, but it can be done with that also. So if it's quadratic, to find the sum, s sub 12 in this case, okay, then we're going to do n times n plus 1 times 2n plus 1 divided by 6. All right, so what's n in this case? 12. So n plus 1 is 13. And if I double it and add 1, what do we get? Okay, 2 times 12 is 24, plus 1 is 25. And then just divide that by 6. Okay, that can be easily typed in your calculator to find the answer also. Okay, what? 650. All right, and their method for showing it on your calculator is just plugging them all in and adding them up. Okay. But the other way you can use your calculator, which we just saw, so if we go alpha, summation, and we went from x goes from 1 212, and of x squared. We also get 650. Okay. Much easier. Okay. All right, so the last one then. Okay. All right, so what if I have a problem I need to solve? Sam is laying out patio stones in a triangular pattern. Your first row has 2 stones, and each row has 2 additional stones, as shown below. How many complete rows can he make with a box of 144 stones? Now, there's many ways to go about doing this, and I would do it the simplest way I know of doing this is just by adding and getting totals. So I'm going to make a table. And my table is actually going to have 3 columns. Let's see. Oops. Okay. My table is going to have 3 columns to it, and I may need to expand it even. Okay. So my first column is going to be the row number. Okay. And this is tiles in the row. All right, and this will be total tiles. Okay. So I'm going to be adding. Okay. So Sam's doing this. He has, well, we got stones instead of tiles, but it's all right. It says, how many complete rows can he make with a box of 144 stones? So let me rewrite this as stones here. All right. So in row 1, he has 2 stones, so my total is 2. In row 2, he has 4, so my total is 6. Okay? Add these numbers up. Okay? Row 3, there are 6 stones, right? So that gives me 12. Row 4 would be 8. So we got 20. And then I'm just going to keep going. Okay, obviously I'm going to need a couple more rows. Okay, so 9 is 18, that would be 90. 10 would be 20, so that would be 110. 11 would be 22, and that would be 132. All right? Could I get another row in? No, because I don't have, I would need 24 more, and that would put me over the 144, so there would be 11 rows of stones. Okay? And those types of problems like that, I would just build a table and find the answer. All right, questions? Ready to get started? No.